Okay, so now we move to the partitioning pattern, and what we do here is, for example, so suppose you have terabytes of data, and the stuff you're doing on that data, probably you're trying to do something. For example, if you have big log, terabytes of log, and then you're trying to do something which is based on the time in the log. For example, you do some analytics for only a month of the data in the log. Now, since you're operating on that smaller chunk of data, to be able to deal with this big chunk, it will take much more longer time for you. So in such cases, it's better to partition the file based on certain timelines, so that when you operate on this data, you actually know beforehand which chunk you want to operate on, and just go ahead and look at those partitions of data rather than looking at the whole bigger chunk. This in some sense looks a little similar to filtering that we had seen yesterday, last week. But the difference here is, if you tend to filter a lot, on certain criteria, then it's better to create a partition of such data, so that you don't have to do that filtering all the time. So if your data set has got a characteristic like that you want, your use case rather has got a characteristic that it tends to operate on such partitions of data, it's actually good to go ahead and create that partition of data upfront. To be able for you to do this, to apply this pattern, you will need to know beforehand the number of partitions that you want to create in your data. Here is a structure. So you have the input splits, and the main crux of this pattern is the partitioner that you will write. As far as other things are concerned, the mapper and the reducer, you could just leave those as identity mappers. But if you want to perform certain functions inside those, you could also do that. But the important thing to keep in mind is actually the partitioner that you will be writing as far as implementing this pattern is concerned. Okay, so as far as SQL is concerned, we do have in our DBMSs the ability to partition tables, and there is also a resemblance here to a pattern which we'll discuss after this, that's called binning, and that's in terms of it looks very similar to partitioning, but as far as the implementation of these two things is concerned, they are quite different. The use cases, generally these are utilized in a very general sense. So partitioning by continuous values. So you have a set of continuous values and create partitions somewhere. If you want to create five different partitions, then you just divide this data maybe in equal partitions or by using some statistical analysis upfront. Or you could do a partitioning which is based on the category. For categorical data, and we'll see an example of the categorical data when I show you the example for partitioning. And you could use it for sharding as well. So our example is going to be about the postlinks.xml file. And in postlinks.xml you have a field which is called the link type ID. And that has two values. One is the two different values, 1 and 3. And one stands for linked data and the other is the duplicate data. So what we'll do is this whole file, link type ID, we're going to partition in two partitions, the linked partition and the duplicate partition. And let's see the code for this. So let me just start from the beginning for this. So you have the input location and then the output location, and then I had supplied the values on which the partition was going to be done. So that's here in the string. So I'm setting a mapper class, the post-link mapper, not using the identity mapper, and then I am setting the partitioner class here, and this is where the chunk of the task for this pattern would be done. And the post-link partitioner that set partitions, you will understand what it actually does when I get to the code for the partitioner. So just keep in mind that I'm actually calling this method, and I will get to that when I get to the partitioner. And then I also set a reducer class, and the number of reducers is 2. And this is 2 because we need to know ahead of time the number of partitions we will be creating, and that's going to be based on the number of reduced tasks. So we set 2 as the number of reducers. Okay, and let's see the partitioner code. Okay, so yeah, so partitioner actually extends the partitioner, and one thing to keep in mind is the key and the value types for the partitioner should be equal to the key and the values which come out of the mapper. So here the partitioner that we have is the key is int writable and the value is text. And as you will see in the mapper, this is what is output, int writable and text from the mapper. And this has to be followed in some of the methods as well. So one of the methods which you need to implement when you are extending from that class is this, the get partition method. Okay. And the get conf or the set conf are the ones which you will implement, because we are also saying that this is a configurable object. But as far as the partitioner is concerned, this is the method which you need to implement, get partition. And get partition is not called by you, it's called by the framework when it's running the partitioner on the output values which are coming out of the mappers. And this is a signature. So this method also takes this key, and this should match with your key and the value types. And then you have the number of partitions. This is also something which this number of partitions is decided by the number of reducers that you had set earlier. And all this method is called by the framework. You don't call this. What we do here in this, okay, before I explain to you this, I'll have to explain the method which is about doing the set partitions, because after specifying which partitioner to use in the driver, you had called this method, right? Set partitions was called. And with this string contained 1 and 3, which I had passed from the command line. So here in this method, you actually set your conf object. It's set the configuration with these partition values. Okay, and then in the set conf, what you do is we have got those two values 1 and 3 as strings, and then we create an array of string lists. Array list of strings in which I put those values. So in this array list, the value at the index 0 is going to be 1, value at index 1 is going to be 3, and that's been put for the logic that I use to get the partition. Okay, so what I do in this get partition is I just get I check whether that value, I get the index for that value. So for 1, I get an index 0. If the value is 3, I get an index 1. So the partitions which are going to be created are going to be numbered 0 and 1. So this is the partitioner class, and we have seen the driver. Let's see the mapper. Okay, so as I said, the thing to keep in mind is this value, the key and the value which you output from the mapper has to match the partitioner, the values the partitioner gets. And what I'm doing in this mapper is I'm getting the link type ID from the post links file, and the output key is set to that ID 1 or 3, and then the value is a whole record. Okay, and on the reducer side, the reducer will get the two reducers, and the reducer will get the value. So this is what it gets from the mapper, which is value 1 and value 3 for two different groups, and all these values inside the iteral values are the records corresponding to that. Let me run this program now. Give me a second for setting this up. So you see so there were two different partitions which have been created. There were two different reducers, so you see these, and these two reducers are based on the number of partitions we're creating. And if you see the data inside, you will see that the data has been partitioned. Okay, so here it is. The link type in the end is 1 for everything in this file. And then let's see the second one. And for all the records, the link type is 3. Okay. So that was about the partition. Okay, so we saw partitioning. Binning is very similar to, in terms of behavior, what partitioning does. But as I said, the implementation is very different. So in partitioner, what you had done is you wrote your own custom partitioner, and the whole data, whatever was passed as input split to the mapper, had to be transferred across the network, and everything went to the reducer side. The benefit of doing binning is you don't transfer the data at all. The whole of binning happens on the mapper side. But one thing you'll have to keep in mind is because everything is happening on the mapper side, and this mapper which is creating those bins, so you tend to create multiple files. So as I'll see in the structure for binning when I come to that slide, this can pose a scalability bottleneck for the name node, because it could, if you have too many partitions, it's not a good idea to use binning. But with small number of partitions, probably it does serve the purpose. And for example, in the kind of data sets we are using, it would have been completely fine to use binning as well. And in this case also, you will need to have a knowledge about the number of partitions before you apply this pattern. So here is the structure for binning. So binning mapper, for example, if I talk about the earlier case, we had the linked data and the duplicate data. Each of these mappers will emit the linked, a file which is going to be about linked and which is going to be about duplicate. And that's going to be done by each of these mappers, and they will be separate files. So that's where I was talking about not using binning if you have too many partitions to use. Even if you had 2 with 3 different mappers running, you will end up with 6 files. So on this slide, of course, the reducer, the combiner, and the custom partitioner are not required. And one thing which you'll see in the code is, in this we'll use, you saw multiple inputs. Here we are going to be using multiple outputs for the bins. And we'll see that in the code. There is something resembling this in Pig, and it's implemented through a split. So you split data into, eighths if this condition is true, into this bin if this condition is true, and into small bins if this condition is true. So 3 different bins are being created using this simple Pig command. Use cases are pretty much similar to what I'm doing. Saying, as I said, don't use if you have too many partitions. And the problem also we are solving here is the same. We solve for partition. Let's see how we solve the same problem and get this result using binning. Let's go to the driver again first. As far as the command line for this concern, that's how it is. You just have to give the input location and the output locations. And then we set the mapper class here, and that's all we have to do. And whatever we do here is going to be inside the mapper. And number of reducers we just set to 0. And then here's what you do with the multiple outputs. So I have created one of the named outputs, and that's called bins. And you will see in the mapper code how we use this. So here we configure the mapper, configure the multiple outputs, and the name of that is bins. And then we'll see how we use it on the mapper side. Okay, so here again we create in the setup over here in the mapper we create this multiple outputs, and then when the mapper is called you see the code here. Okay, so the logic is again simple. So we just read the link type ID from post links file, and then based on whether that value happens to be 1 or 3, we take a decision about writing it to that bin. Okay, so here it is. So if this is true, we write to the same bins, but this is the name of that file, which is called linked here. Okay, and then in the second case, that's actually called duplicate. Okay, and if you have, for example, if you're running only one mapper, then linked and the duplicate files, one linked and one duplicate file you will see in the output directory. If your program happened to have more than one mapper was actually run for your program, then in that case you will see separate linked and the duplicate files for each of those mappers written out. Okay, so actually in the cleanup we go ahead and close this M outputs. Let's see, I mean there's no other code here, so let's see how this executes. Okay, so as far as the input location is concerned, this is the place where postlinks.xml is stored, and then this is the output location. So let's run this. Okay, let's check the output. Let's see what's there in the output directory. Fine, here it is. So as I said, right, so you have one file called duplicate, the other is linked, and in our case only one mapper was run, so we see output only from one. If you had more, you would have seen more. And just check if it has done the same thing which we had seen in the partitioner. Yeah, so duplicate is all three as far as the linked ID is concerned. Let's see if the other one also has the right data. Sorry, so as far as linked file is concerned, you see the link type ID equal to 1. So yeah, so the partitioning was done properly, completely on the mapper side, and the results are same as you had seen in the partitioner pattern.